everyone. Now we are going to talk about the logical database design. Before designing our database, we need to know there are two ways that the information is being viewed in a database. One of them is called the physical view, and the other one is logical view. Physical view involves how data is stored on and retrieved from storage media such as hard disk, magnetic tapes, or CDs. The logical view involves how information appears to the users and how it can be organized and retrieved. There are more than one logical view of the data, and it depends to the users. So for example, marketing manager might want to see the top selling product in a specific region, whereas HR manager might want to see the top paid employee by a specific region. So what is a data model? So before designing our database, the first step is to come up with a data model or a blueprint. Data model determines how data is created, represented, organized, and maintained. It contains three main components. First is the data structure, second, operation, and third, integrity rules, which defines the boundary of a database. Data structure describes how data is organized and also the relationship among the records. Operation describes methods such as calculation and so forth, and what are the actions that can be performed on the data, such as updates, querying, or deleting. Integrity rules defines the boundaries of a database, such as maximum and minimum values allowed for field constraints, limits on what type of data can be stored in a field, and also how it can be accessed. So in a hierarchical model, which you can see here, the relationships among records form a tree-like structure. The tree-like structure is like a hierarchy. Records are being called as nodes, and relationship among records are being called as branches. So these are branches, and this is a node. The node at the top is called root, and every other node is being called a child. So we will have a child-parent relationship. Nodes with the same parents are called twins or siblings. Each product line has its own category in here. And each category has a specific product. For example, supplier A could have three different products, such as soap product, shampoo product, and toothpaste product. The toothpaste product has two lines of category: whitening and cavity-fighting toothpaste. And the other one, the other product has maybe three different kind of categories. And then another product line could have maybe another two kind of categories. Another model is called the network model, which is similar to the hierarchical model, but records are organized differently, as you can see here. So in this model, it links the invoice number, customer number, and methods of payment. For example, invoice 111 belongs to the customer 2000, who paid with cash. Unlike the hierarchical model, each record in the network model can have multiple parent and child records. So a customer can have several invoices, such as an invoice can be paid by more than one method, such as cash or credit. So now we will talk about a relational model. A relational model uses a two-dimensional tables, which we call them rows and columns. Rows are records and sometimes can be called tuples. And columns are fields, which sometimes we can refer to them as attributes. To begin designing our relational database, we must first define the logical structure by defining each table and field in it. For example, the student table has fields for student ID, first name, last name, and so forth. The collection of these definitions is stored in something called data dictionary. Data dictionary can also store other definitions, such as data type for each field, their default value, and some kind of a validation rule for data. So field name, as we said, it could be a student name, admission date, age, major, and the data type could be maybe a student name, could be a character. Admission date could be a date, and major could be a number. So a data dictionary stores basically definition and data types for each field, and also maybe some default values and validation rule. Also in a database, we have something called primary key, which uniquely identifies every record in a relational database, such as student ID numbers, account numbers, social security numbers, invoice numbers. Foreign key is a field in a relational database that matches the primary key column of another table. This can be used as a cross-reference table. Also, in a relational databases, we have another topic and a key term, which is called normalization. To improve the database efficiency, we need to use this normalization. So what does that mean? Which means we have to eliminate redundant data, such as making sure that customer names are stored in only one table, and making sure that only related data is stored in that table. Normalization can go through different stages. For example, we could have first normal form all the way up to fifth normal form. Many organizations typically make sure that their database is between first normal form through third normal form. So in a normalization, we try to eliminate duplicate fields from the same table. We will create separate table for each group of related field, and we identify each record with a unique field, which is called primary key. So in data that can be stored in a relational databases can be retrieved from table by using different operations, such as selecting, project, join, intersection, union, difference, and these can all be used to be able to retrieve information from those tables.